First of all, hello everybody. Thank you so much for taking the time to come and visit my presentation. So my name is Zal Ekinci. I am a senior at Johns Hopkins, double majoring in chemistry and biology. And before Hopkins, I actually went to high school in Turkey, and I went to TED Istanbul High School. Right now, I live in New Jersey, though. But yeah, I just want to get into the research project real quick. So my project is the synthesis of a novel triboluminescent cobalt complex. And this project was very challenging for me because I'm dabbling with a side of chemistry that is pretty relatively new, triboluminescence, and the paper that I based my research off on that was written by Gazik et al., which I referenced in my abstract section here actually came out in 2023. So it's very new. And I've had hurdles and a lot of challenges trying to work through this project as I'm reading the literature intensively and all, and I'm also talking with my professors, with Dr. Huang, who teaches advanced inorganic chemistry lab, who helped me come up with this project, helped me get my chemicals, and helped me set up the lab for this project, and also Dr. Carlin and Dr. Falzone, who provide me with a lot of guidance and mentorship in preparing this presentation, this project, and just critically thinking about problem solving in chemistry. So I'm really grateful for all of them and all their help for this project. But yeah, quickly going into the project, what I am interested in doing through this project is to attempt to create or simulate, more or less, the electronic ligand properties in the ligand field that we see at the cobalt complex. So I was basically trying to replicate that in the copper complex. I was trying to replicate that in the cobalt complex, and I wanted to observe if I'm going to be able to see triboluminescence with cobalt. So the main challenge that I faced in my project was I was actually interested in doing this with silver, which has a lot more similar properties to copper, which was what was used in the original paper. And this is because they're in the same group in the periodic table. Cobalt, on the other hand, is in the same period with copper, which is not the most ideal, I'd say. It's just that costs and a lot of other things resulted in me using cobalt, trying to use cobalt, which is challenging because cobalt is a plus two oxidized metal, at least in my project, since I'm using cobalt thiocyanate for my source of cobalt and thiocyanate. So yeah, it's been challenging, but that's real science, and I get to experience what it means to truly do research because I'm dabbling in basically the unknown with the guidance of my professors, and I'm getting to experience how I can apply chemistry and biology and all my STEM knowledge into critical problem solving to try to navigate my way through this complicated project while I'm trying to develop something that hasn't been done before. And yeah, I did not get the results that I expected. I got a pink crystal, which I'm still working on characterization. And I was not expecting that. I was expecting a blue complex, but it's still a pretty fascinating discovery for me, a pretty fascinating result. So I'm going to be working more in depth and trying to characterize this chemical and trying to see what else I can do with it. Uh, yeah, that's more or less all I have. Thank you so much for stopping by, and I'm looking forward to talking with everyone in my session. And yeah, it's very exciting to be a part of Dreams. I am very grateful for Hopkins and Hour for giving me this opportunity. Thank you.